Next one is multiplication theorem on expectations. What the theorem states that if x and y are two independent random variables such that expectation of xy less than infinity, then e of xy equal to e of x into e of y. So here we take the random variables x and y are independent. Note the point, independent random variables. We have already learned that what's the property of independence. Independence in a property and then if x and y are two independent random variables, then f of xy equal to f of x into f of y. Clear? If x and y are two independent random variables, then f of xy equal to f of x into f of y. We can apply this property here. Okay. Let x and y are two discrete random variables with the joint PM of f of xy. Then നമ്മൾ ആദ്യം എടുക്കുന്ന x ഉം y ഉം discrete random variable ആണ്, അവരുടെ joint PMF ആണ് f of xy. Then what's the definition of e of xy? E of xy equal to summation over x, summation over y, xy into f of xy. Okay, summation over x, summation over y, xy into, we can apply the property here, f of xy equal to f of x into f of y. Clear? I will rewrite this as summation over x, x into f of x into summation over y, y into f of y. Clear? What is this? This is expectation of x into expectation of y. Okay, so we prove the result in the case of discrete random variables. Next we take x and y are two continuous random variable with the joint PDF f of x. Let x and y be two continuous random variables with the joint PDF f of xy. Then what's the definition? E of xy equal to, instead of summation we take integral here. Okay, integral over x, integral over y, xy into f of xy dx dy. Clear? That is equal to integral over x, integral over y, xy into, we apply the property of independence, f of x into f of y dx dy. Okay, I will rewrite this as integral over x, x into f of x dx into integral over y, y into f of y dy. Okay, what is this? This is expectation of x and this is expectation of y. That is, we can write it as expectation of x into expectation of y. That is, expectation of x plus y equal to, sorry, x into y equal to expectation of x into expectation of y. We have proved the result in both the cases. Clear? Now we can extend the theorem to n number of random variables. Suppose we take x1, x2, etc. xn are n independent random variables. Then നമ്മൾ ആ result n number of times ലേക്ക് apply ചെയ്യാം. Then what is that? Expectation of x1 into x2 into etc. xn equal to expectation of x1 into expectation of x2 etc. expectation of xn. What does this mean? Expectation of the product of n random variables is equal to product of their expectation. Clear? Symbolically we can write it as expectation of product I from 1 to n xi equal to product I from 1 to n expectation of xi. Clear? Next theorem. If x plus y of t equal to mx of t into my of t. നിങ്ങളിവിടെ പ്രത്യേക ഒരു കാര്യം ശ്രദ്ധിക്കണം, ഇവിടെ പ്ലസ് വരുമ്പോൾ ഇവിടെ മൾട്ടിപ്ലിക്കേഷൻ്റെ സൈനാണ് വരുന്നത്. അപ്പോൾ എം ജി എഫ് നമ്മൾ ഉപയോഗിക്കുമ്പോൾ പ്ലസ് ആകുമ്പോൾ ഒരിക്കലും ഇവിടെ നിങ്ങൾ അറിയാവുന്ന പോലെ എന്തുണ്ട്, ഇത് എഡിഷൻ ചെയ്യരുത് കേട്ടോ. ദിസ് ഇസ് ദ പ്രോപ്പർട്ടി ഓഫ് എം ജി എഫ്. ഓക്കെ, അപ്പോൾ നമ്മൾ യൂണിവേരിയേറ്റ് കേസിൽ എങ്ങനെ, ഹൗ വി കൺസിഡർ ദ എം ജി എഫ് mxt, mgf of a univariate random variable mxt. What's the definition? Expectation of e raised to tx. Right, we can extend this to a bivariate case. എന്താ വരിക പറഞ്ഞേ, mx plus y of t equal to expectation of e raised to, in the case of x we will write here x plus y, tx plus y. Clear? Split ചെയ്യാം നമുക്ക് expectation of e raised to tx plus ty. Clear? Okay, we can use the identity principle here. You have already studied about the identity principle. What is that? A raised to m plus n equal to a raised to m into a raised to n. Right, we can apply this property here. What is this? What is here? E raised to tx into e raised to ty. Here, since x and y are two independent random variables, we can split this as expectation of e raised to tx into expectation of e raised to ty. Okay, what is this? This is the mgf of x and this is the mgf of y. Here we can write it as mx of t into my of t. That is mx plus y of t equal to mx of t into my. Next theorem, if x1, x2, etc. xn are n independent random variables, then m summation xi of t equal to I from 1 to n equal to product I from 1 to n mxi of t. Okay, here we take n random variables. N random variables are independent. Okay, m summation I from 1 to n xi of t. By definition we can write this as expectation of e raised to t. Instead of x we can write summation xi I from 1 to n. Okay, expectation of e raised to, summation can be taken outside, summation I from 1 to n txi equal to expectation. Since x1, x2, etc. xn are independent, we can write this as summation. Instead we write product I from 1 to n e raised to txi. Clear? Product can be taken outside. Product I from 1 to n expectation of e raised to txi. What is this expectation of e raised to txi? That is the mgf of xi. That is product I from 1 to n mxi of t. This is the case of n number of independent random variables. Okay, now we have a result. Result 1. For a pair of random variables x and y, the covariance between x and y is defined as covariance of xy. You know, covariance of xy is written as co-xy equal to expectation of x minus e of x into y minus e of x. This is the standard formula for co-xy. Covariance of xy equal to expectation of x minus e of x into y minus e of y. Okay, we have another xy minus expectation of x into expectation of y. Another formula for covariance of xy equal to e of xy minus e of x into e of y. We want to prove this result. Okay. Proof. Start with the covariance of xy. Covariance of xy equal to, what is the standard formula? Expectation of x minus e of x into y minus e of y. Okay, that is equal to expectation of simply the multiplication x into y, xy minus x into e of y, x into e of y minus e of x into y plus e of x into e of y. Okay, then expectation can be taken inside. Expectation of xy minus expectation of x into expectation of y minus expectation of x into expectation of y plus expectation of x into expectation of y. We can cancel these two terms. Okay, we can write expectation of xy minus e of x into e of y. That is covariance of xy equal to expectation of xy minus expectation of x into expectation of y. You have to study both the formula. Covariance of xy equal to, this is the standard formula and this is the another formula for covariance of xy. Okay, next result. Result number 3. Okay, if x and y are two independent random variables, then covariance of xy equal to 0. Covariance of xy equal to 0. X ഉം y ഉം independent random variables ആണെങ്കിൽ covariance 0 ആയിരിക്കും. Simple proof ആണ്. Proof. What is the formula for co-xy? Co-xy equal to, we can use the second formula. Expectation of xy minus expectation of x into expectation of y. Okay, we have given that x and y are independent random variables. So we can take the multiplication theorem on expectation. Then what is expectation of xy? Expectation of xy is expectation of x into expectation of y. What's the reason? Because x and y are independent random variables. Minus e of x into e of y. We have to write the reason here. Since x and y are independent. X and y are independent. Clear? Okay. Then what is expectation of x into expectation of y minus expectation of x into expectation of y? Simple. That is same. Clear? Next result number 4. The correlation coefficient between x and y is defined as, correlation coefficient എങ്ങനെ എക്സ്പെക്ടേഷന്റെ കേസിൽ പറയാ? correlation നിങ്ങൾക്കറിയാം rho xy or pxy. rho xy equal to co xy divided by root of variance of x into root of variance of y. Okay, where what is covariance of xy? We have already learned that co xy equal to e of xy minus e of x into e of y. Right, then what is variance of x? Variance of x equal to square root of e of x square minus e of x the whole square. Then what about variance of y? Variance of y equal to square root of e of y square minus e of y the whole square. E of y the whole square. This is the formula for correlation in the case of expectation. Clear? Next result, Schwarz inequality. For any two random variables x and y, e of xy the whole square less than or equal to e of x square into e of y. E of y square. Okay. Now we prove the result by taking a real number lambda. Let lambda be a real number. അങ്ങനെയാണെങ്കിൽ ലാംഡ എക്സ് മൈനസ് വൈ ദ ഹോൾ സ്ക്വയർ ഇസ് നോൺ നെഗറ്റീവ്. ഒരു നമ്പർ, ഒരു റിയൽ നമ്പർ, ആ റിയൽ നമ്പറിന്റെ സ്ക്വയർ ഇറ്റ് ഓൾവേസ് പോസിറ്റീവ് ആയിരിക്കും അല്ലേ? അങ്ങനെയാണെങ്കിൽ അതിന്റെ എക്സ്പെക്ടേഷൻ എടുക്കുമ്പോൾ എക്സ്പെക്ടേഷൻ ഓഫ് ലാംഡ എക്സ് മൈനസ് വൈ ദ ഹോൾ സ്ക്വയർ ഇസ് നോൺ നെഗറ്റീവ്. അതും എന്തായിരിക്കും? നോൺ നെഗറ്റീവ് ആയിരിക്കും. Okay, then expectation, consider expectation of lambda x minus y the whole square. What is this? We can expand this by നമ്മൾ പഠിച്ചിട്ടില്ലേ a minus b the whole square. അത് വെച്ചിട്ട് ചെയ്തു നോക്കൂ. Expectation of what is this? A square lambda square x square minus 2 lambda xy 2 lambda xy minus plus b square. What is that? Y square. Okay, expectation can be taken inside. That is lambda square. Lambda is a constant, so expectation of a constant is constant. We have already learned that. A lambda square into expectation of x square minus 2 lambda into expectation of xy plus expectation of y square. Okay, this is the quadratic equation is in lambda. Said that here lambda x minus y the whole square is non-negative. That is, it is always positive, greater than or equal to 0. That means this is always greater than or equal to 0. This is always greater than or equal to 0. And this is a quadratic equations in lambda. ഇവിടെ എന്താ പറയുന്നത്? quadratic equation is lambda is always greater than or equal to 0. Therefore, the discriminant must be negative. What do you mean by discriminant? Discriminant നിങ്ങൾ പഠിച്ചില്ലേ? b square minus 4ac. അത് എപ്പോഴും എന്തായിരിക്കണം? എപ്പോഴും must be negative. 0 less than or equal to 0 ആയിരിക്കണം. Then what is that? Since this is a എന്താ നമ്മൾ പറയാ? This is a quadratic equation in lambda which is greater than or equal to 0. Therefore, its discriminant must be negative. The discriminant must be negative. That is b square minus 4ac less than or equal to 0. എന്താ അപ്പോൾ b square വരിക? പറഞ്ഞേ b square. b square 2 into expectation of xy 2 into expectation of xy the whole square b square. ഇവിടെ മൈനസ് ഉണ്ട് അല്ലേ? ഓക്കെ, minus 2 into expectation of xy the whole square b square minus 4 into what is a here? Expectation of x square into c എന്താ അവിടെ? expectation of y square which is negative എന്നല്ലേ പറഞ്ഞത്? less than or equal to 0. 0 താഴത്തേക്ക്. അപ്പോൾ ഇതെന്താ വരിക? സ്ക്വയർ എടുത്താൽ 4 into expectation of xy whole square minus 4 into expectation of x square into expectation of y square less than or equal to 0. Okay. That is 4 into expectation of xy the whole square. This term can be taken on the right side. Less than or equal to 4x square into expectation of y square. Okay, 4 നമുക്ക് എന്ത് ചെയ്യാം? Cancel ചെയ്യാം. We can cancel 4 in both sides. അപ്പോൾ എന്താ കിട്ടുക? expectation of xy the whole square less than or equal to expectation of x square into expectation of y square. This is Schwarz inequality. Next result, if x and y be a pair of random variables, then rho xy minus 1 less than or equal to rho xy less than or equal to 1. What do you mean by rho xy? Rho xy എന്ന് പറഞ്ഞാൽ എന്തായിരുന്നു? Rho xy is the correlation coefficient between x and y. നമ്മൾ പഠിച്ചിട്ടുണ്ട് correlation coefficient is lies between -1 and +1. Okay, here we prove the result in the case of using expectation. Okay, then proof. We have already learned that rho xy, in the rho xy formula, in the case of expectation, rho xy equal to covariance of xy divided by square root of variance of x into square root of variance of y. ഓരോന്ന് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്ത് കൊടുക്കുക ഫോർമുല. എന്തായിരുന്നു? ഞാൻ ഇങ്ങോട്ടേക്ക് എഴുതുന്നുണ്ട്. rho xy equal to covariance of xy. What's the formula? Expectation of standard formula, expectation of x minus e of x into y minus e of y. First formula, divided by square root of e of x square standard formula ആണ് നമ്മൾ പറയാൻ പോകുന്നത്. Expectation of x minus e of x the whole square, then what is variance of y, square root of e of y minus e of y the whole square. Okay, put x equal to e of x, x minus e of x equal to small x and y minus e of y equal to small y. അല്ലേ? അപ്പോൾ എങ്ങനെയാണ് rho xy വരിക? അവിടെ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്ത rho xy equal to e of small xy divided by square root of e of small x square into square root of e of small y square. Squaring on both sides. അപ്പോൾ എന്ത് വരും? rho xy the whole square equal to expectation of xy the whole square divided by, താഴെ സ്ക്വയർ ചെയ്യുമ്പോൾ എന്താ സംഭവിക്കുക? സ്ക്വയർ റൂട്ട് ഒഴിവായി പോകും. അപ്പോൾ എന്താ വരിക? expectation of x square into expectation of y square. We are familiar with these two terms. എന്തായിരുന്നു അത്? ഷ്വാർട്സ് ഇൻഇക്വാളിറ്റി നമ്മൾ പഠിച്ചിട്ടുണ്ടായിരുന്നു. ഷ്വാർട്സ് ഇൻഇക്വാളിറ്റി എന്തെന്ന് പറഞ്ഞാൽ എക്സ്പെക്ടേഷൻ ഓഫ് എക്സ് വൈ ദ ഹോൾ സ്ക്വയർ ലെസ് ദാൻ ഓർ ഈക്വൽ ടു എക്സ്പെക്ടേഷൻ ഓഫ് എക്സ് സ്ക്വയർ ഇൻടു എക്സ്പെക്ടേഷൻ ഓഫ് വൈ സ്ക്വയർ. ഓക്കെ, അപ്പോൾ ഇങ്ങോട്ടേക്ക് എടുത്ത ഈ ക്വാണ്ടിറ്റി എക്സ്പെക്ടേഷൻ ഓഫ് എക്സ് വൈ the whole square divided by expectation of x square into expectation of y square less than or equal to 1. Okay, we can use this result here. അപ്പോൾ എന്താ വരിക? This is less than or equal to 1. Clear? Okay. അപ്പോൾ നമുക്ക് ഇവിടെ എന്താ എഴുതുക? rho xy the whole square less than or equal to 1. അങ്ങനെയാണെങ്കിൽ modulus value of rho xy less than or equal to 1, which implies minus 1 less than or equal to rho xy less than or equal to 1. Hence the proof.